Welcome to the webinar on critical path method. It is one of the prominent project scheduling technique we will be using in our day-to-day life. In this webinar, we are going to learn how to calculate early start, early finish, late start, and late finish for an activity, how to perform a forward and backward pass analysis through a network diagram, calculate project duration and critical path, and how to calculate float and free float for an activity. Let us understand some of the basics for understanding the critical path method. The one of the first technique is how to calculate early start, early finish, late start, and late finish. Let us take a very common example. For example, the context is by 10 a.m. we have to be at office. That means if you reach the office by 10:01, that means 10 hours and 1 minute, assume that a leave will be deducted. So by 10 a.m. mandatorily an employee has to be at office. So that's a hard deadline. So the activity here is called commute to office from home, and it takes 1 hour. Keeping this example, let us understand what is early start, early finish, late start, and late finish. As I said just before, we can start at 8:30 a.m. at the earliest. That means before 8:30, the employee cannot start in this example. So 8:30 a.m. is what is the earliest start time an employee can start. So that is there in the left top mark here, early start. So the activity here is called commute to office, and this activity takes 1 hour. So if he starts at 8:30 a.m., which is early start, if you add duration to this, that is early start plus duration, it gives you early finish, which is 9:30 a.m. So by 9:30 a.m., we will be reaching the office. So that is the early finish. So in this example, we have seen what is early start and what is early finish. The formula is early finish is equal to early start plus duration. So in this example, you still have a half an hour buffer to reach your mandatory time, which is 10 o'clock. Assuming that you have to reach by 10 a.m., that you have to start at your home at 9 a.m. That means your late start is 9 a.m. and if you add duration to your late start, that is 1 hour, it gives you 10 a.m. So we have introduced 4 keywords: early start, which is 8:30 a.m. and if you add duration on top of it, you will get early finish, which is 9:30 a.m. Similarly, late start, which is 9 a.m. If you add duration of 1 hour on top of that, you will reach late finish. Friends, we will be using this notation of representing early start, early finish, late start, and late finish for the activities we are focusing in this session. Let's take one example here. If an activity A takes a duration of 5 days, and if 10 days is what is early start, so if you add 10 plus 5, which is equal to 15 days, is what brings you to early finish. So early finish is equal to early start plus duration. Similarly, late start is 15 days in this example, and if you add 5 days to this, it becomes 20 days. So late finish is equal to, which is 20 days, is equal to 15 days, which is the late start, plus duration 5 days. So this is the another example just to bring you how to denote early finish, early start, late finish, and late start. With this, let's get into an example. The example is like this. You will be given activities in this way. Activity A, B, C, D, E, F, E, I, and R. And the predecessors are given below. and the duration of activity. That means activity A takes 5 days. Activity B has a predecessor A and it takes 6 days. Activity D has a predecessor A and it takes 4 days. Activity C has a predecessor B and it takes 14 days. Activity E has a predecessor D and takes 6 days, and so on. So if we have to draw a rough draft of network diagram, I have represented activity A here, and this activity A is the first activity for me because it does not have any predecessor here. Now, if you come to the second row, it says activity B has a predecessor A. So that's why activity B has a predecessor A. So if you go here, activity D is also having predecessor A. Now activity C has a predecessor B. Similarly, activity E has a predecessor D. Now if you say I, it has two activities C and E as its predecessors. Now finally, you have activity R, which has predecessor I. So friends, if you redraw this particular example, you actually bring a typical nodes here: activity A, B, C, D, E, I, and R. Whatever we have represented in this diagram, we are just bringing the precedence diagramming method here. So activity A, activity B, activity C, and in this flow D and E, I and R. If you see this, it is a simple example I have taken. In any IT example or in any construction projects, let us assume that you do requirement analysis for 5 days. That is activity A. And you have two different modules. Module B and C. Module B takes 6 days for design and 14 days for building and testing. Similarly, module B, it takes 4 days for designing and 6 days for building and testing. So module A is the path of B and C. Module B is the path of D and E. Now, after you complete these two modules, you integrate it. That's why you have integration and testing for 5 days. So naturally, B and C are completed. That means one path is completed. So you integrate it with the other path D and E. And then finally you do regression and release for 5 days. So this is the summary. So it's a very simple example I have taken, okay, where you conduct requirement analysis for 5 days and then it branch off into two different modules, and B and C represents one module and D and E represents another module. So once both modules are completed, then you integrate them and then finally you do regression and release. So if we actually bring a network diagram for this, it becomes A, B, C, D, E, and then the I stands for integration, R stands for regression and release. Okay. So if you see here, A comma 5, that is this activity A takes 5 days and activity B takes 6 days. So duration is represented right after the activity. Now let us understand how to perform forward pass and backward pass. So in forward pass, you start from left and you go towards the end. Okay, here if you see activity A, let us assume that we start at the end of 0th day. You complete this particular activity at the end of 5th day. So 0 plus 5 means early start plus 5, which is duration, gives you the earliest finish. This is what we have understood in our earlier example. So let us say now this particular activity has early start of 0, early finish of 5 days. Now this 5 days will come as early start for activity B. So if you see here, the same 5 days here becomes the early start for activity B, and the same 5 days will become the early start date for activity D. Now again, if you add duration on top of that, is 5 plus 6, it becomes 11. So this early finish for activity B is 11. Similarly, early finish for activity D is 5 plus 4, 9. So the same 11 will be brought forward here because the earliest finish of activity B will become earliest start for activity C. So the same 11 has brought forward here as earliest start. Similarly, in below example, the earliest finish, which is 9 days, is brought forward here as earliest start, which is 9. Now, if you add duration on top of that, that is 11 plus 14 is equal to 25. So the earliest finish for activity C is 25 because we just added 14 days, which is duration for activity C, to its earliest start date. Similarly, if you come down to activity E, we get early finish as 15 days because earliest start is 9 days. 9 plus 6 is 15 days. Now, as usual, there is two ways. For example, the moment you actually come down to integration activity, which is I, from this path, 25 should be the earliest start date. From this path, 15 should be the earliest start date. Now, in forward pass, you take maxima. It makes logical because unless this path gets completed, this path is getting completed early, but however this path is taking more time, so it is taking 25 days to complete it till then. However, activity E is taking 15 days to complete till this, but both activities should be finished for activity I to get started. That's why you have to take maximum here. That's why, as a rule of thumb, we remember this as take maxima in forward pass. That's why because you are getting 25 from here, 15 from here, we will take earliest start date for activity I as 25 because we have to take maxima in forward pass. So if you add 5 days of duration for activity I to earliest start date, you will get 30 days. Now, as usual, this 30th day, 30 days will become earliest start date for activity R, and if you add 5 days of duration for earliest start date of 30, it becomes 35. So friends, we have completed the forward pass for the entire network diagram that is available here. So what it means, in forward pass, we actually determine early start and early finish. Let us understand how to calculate backward pass. Backward pass means we start at the extreme right. That is, we know that this project is taking 35 days. So the latest finish we should start in backward pass is 35, latest finish. Now we come back. So 35 minus 5, that is latest finish minus duration for the activity R, brings you to latest start, which is 30 days. Now the same 30 days will get carry forward here. So now the same 30 days minus 5, which is duration, gets you to 25. Now this 25, which is late start for the activity I, will get pushed or will get transformed to activity C as well as activity E. So both activity C and activity E will have their latest finish as 25 and 25. Now late finish minus duration for activity C gives you the late start. So for activity C, the late start is 11, and for activity E, the late start is 19, which is obvious because 25 minus 6 is equal to 19 for the activity C. So so far we have determined the late start and late finish for activity C and E, I and R. Now, if you see the same, this is late start of activity C will become the late finish for activity B. So that's why the 11 is getting carried forward here. 19 is getting carried forward to activity D. Now, the late finish minus 6, which is duration for activity B, gives you 5. So this is the late start. So late finish for activity B is 11 and late start is 5. Similarly for activity D, the late finish is 19. 19 minus 4, which is duration, gives you the late start. Now the tricky things comes over here. From this path, from B, 5 is getting carried forward. From D, 15 is getting carried forward. The rule is take minima in backward pass. So that's why you have to take 5 because 5 is the minimum. So now late finish for activity A is 5. Now you have 0 as the earliest finish for activity A because 5 is the late finish. Late finish minus duration is equal to early finish. So this is how we can calculate the backward pass. So using this symbol like an activity, duration, early start and early finish on the top of this activity, late start and late finish on the bottom of the activity, with this presentation we calculated the forward pass and thus calculated early start and early finish. The backward pass, thus we calculated late start and late finish for all the activities in front of us. So friends, with this background, now we can calculate what is critical path and project duration. Now, this is the network diagram we constructed so far with early start date and early finish in red color and late start and late finish date in green color for all the activities. Now the critical path is the longest path in a schedule network diagram. So here you have two paths available. First path is A, B, C, I and R, whereas other path is A, D, E, I and R. So if you take the path 1, which is A, B, C, I and R, the network path duration is, we have to add the duration for all the activities in this particular path. So 5 plus 6, 11, 11 plus 14, 25, 25 plus 5, 30, 30 plus 5, 35. Similarly, if you take another path here, which is A, 5 plus 4, 9, 9 plus 6, 15, 15 plus 5, 20, 20 plus 5, 25. So the path 1, which is A, B, C, I and R, is giving you 35 days, whereas A, D, E, I and R, which is taking 25 days. So the longest path in a scheduled network diagram is called critical path. So in our example, the critical path is A, B, C, I and R, which is highlighted in red color. Now, the critical path also represents the minimum duration a project takes to finish. Okay, because I definitely need 35 days to complete this project. Minimum duration I need is 35 days. That's why critical path provides the minimum duration a project takes to finish. Also, any delay to the activities on the critical path will certainly delay the project total duration. That's why activity A, B, C, I and R cannot be delayed. Any delay to these activities will delay the project end date. And on critical path, that is the path that is represented in red color, we do not have any float. So my dear friends, I use the term float. So what is float? Let us understand. Float or total float, both are one and the same. Some people use the term slack. So either you use the term float or slack, they are one and the same. Similarly, float and total float both are same. It is amount of time an activity can be delayed without impacting the overall project end date. That means if you take here activity A, if you focus on it, okay, the total float is 0 because any delay to this activity, okay, will cause the total delay to the overall project. So let us see how I'm calculating in the next example. So activity A, the float is 0. Similarly, activity B, the float is 0 because instead of 6 days, if it takes 7 days, the overall project duration will increase from 35 to 36 days. That's why all activities on critical path, they have 0 float because we cannot delay the critical path by any day. So on critical path, all activities cannot be delayed. So if you delay by 1 day or 2 days, it will have corresponding effect on overall project end date. That's why the total float or float for all activities on critical path, that is A, B, C, I, and R, is 0. However, if you come down to activity D here, okay, D and E can be delayed by 10 days. How? You see here, now by the time you complete this particular path, okay, you're actually taking 15 days to complete. Now you have to wait till 25 days before activity C gets completed. That means you have 10 days of cushion here. So either the activity D or the activity E, if they are delayed by 10 days, nothing happens to the project. That's why both activity D and E can be delayed by 10 days, whereby they won't impact the overall project duration. That's why the total float for activity D is 10 days. The total float for activity E is 10 days. Now let us understand what is free float. Free float is the amount of time an activity can be delayed without impacting the earliest start date of its succeeding activity. For example, if you take activity A, if I impact by 1 day, activity B can get delayed. That's why the free float of activity A is 0. Similarly, I cannot delay the activity B. Any delay to activity B will delay the activity C. That's why the free float for activity B is 0. Similarly, the free float for activity C is 0, because all activities on the critical path has a free float of 0, because they cannot be delayed. If they delay by any 1 day, then it will impact not only its succeeding activities but also the overall project duration. But anyway, when you talk about free float, you only focus on the early start date delay of the next activity. That means that's why activity A, B, C, I, and R cannot be delayed. Now, if you take activity D, if any delay happens on activity D, will impact the start date of activity E. That's why the free float of activity D is 0, because in free float, you focus on the impact you cause to its succeeding activity. So for the activity D, the succeeding activity is E. So any delay that gets caused for the activity D will delay the activity E. That's why D cannot be delayed. However, if you come to activity C, okay, this can be delayed by 10 days, because the earliest finish is 15 days, but you have to wait till 25 days. That means even if the activity E is delayed by 10 days, you do not need to inform anybody. So that much cushion is there. So the free float for activity E is 10 days, because even if we delay the activity E by 10 days, nothing will happen to its succeeding activity, which is I. So that's why the free float for the activity E is 10 days. Let us understand the significance of critical path method in real-time scenario. As a project manager, we have to use our expertise and bring value to the ground. See, the technical experts or the test experts, they come up with estimates for the activity, but our share of value comes in sequencing those activities, setting up relations for this particular thing, making sure that there's a visual representation of those activities. Maybe we can use tools like Microsoft Project Plan, and make sure that we calculate different paths available in the network diagram, and tell the team that the project takes minimum duration as this is my critical path, and the path, if it is a critical path, for example, in our scenario, A, B, C, I, and R are critical path, whereas I have a schedule flexibility in activity D and E, because I can delay by 10 days. So this way, on the ground, we can show our value of bringing value and quality to project schedule network diagram, or project time management, or project schedule. In reality, my dear friends, critical path method is one of the brightest tool you have at hand, where you can show elegant schedule using this particular method. So it provides you the path which is quite riskier, because the activities on the critical path cannot be delayed. That means there is a risk associated for all the activities on the critical path, because any delay to these activities will delay the overall project. Again, in certain projects, once you complete your project scheduling, you may come across a situation wherein you may have 2 or 3 critical paths. So that is even more riskier, because if you have one critical path, you will have to spend good amount of time in making sure that activities on that critical path is not delayed any further. But however, if you have multiple critical paths, that means the riskier activities are increasing. That means it's a greater risk to project. So you have to tell, guys, we have to do something to make sure the critical paths are reduced to 1. Then only we can reduce the risk factor to the project. So ultimately, it brings value to the profession of project management. It brings structuredness to the scheduling mechanism. It brings visual representation and brings common awareness to all people on the ground. And also it gives you which path is having scheduling flexibility. It also tells you what is the risk associated with each network path, and it helps you control the risk to the time management or project schedule. I really thank you your interest to learn. I hope this session has added value and it enabled you to draw critical path method, and these topics are you are getting refreshed through this session.